Hello 10th class students. So we are about to finish the current academic year as per the government guidelines. We are into the last chapter, current electricity. This chapter is very important for you in future, as well as in any competitive exam what you will be writing in the further studies. So do watch this particular video which I am giving you. These are the list of videos, and these videos are of very big length. Okay, so watch them again and again till you understand each and every concept clearly. I repeat, watch these videos again and again till you understand the concepts clearly.
Hello friends, this video on electricity part 6 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 5 before going ahead with part 6. Now, on the basis of whatever we studied so far, what all did we study? We studied what is electric current, what causes electric current, who carries electric current, and Ohm's law. This is all that we have studied so far. So let us try to solve problems based on all these concepts. So here comes problem number 1. It says a copper wire has a diameter of 0.5 millimeters and resistivity of 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohms? Okay, another thing which I missed to mention is that what is the unit to measure resistance? SI unit to measure resistance is ohm, which is denoted by this symbol. This is the symbol to denote ohms. Okay, so now in this case, the diameter of the wire is given as 0.5 millimeter. Resistivity, that is the specific resistance, rho, is given as 1.6 into 10 to the power minus 8 ohm meter. What will be the length of the wire to make its resistance 10 ohms? Right? So let us solve the first part of the problem. It says what will be the length of the wire. We have to calculate the length. Now from the expression of resistance, we know that R is equal to rho L by A. So from this we can say L is equal to RA divided by rho. So we can put the values of R into A. What will be A? If diameter is given as 0.5 millimeters, that implies that area will be equal to pi R square. So R will be nothing but diameter by 2 because R is the radius. So this will be pi D by 2 whole square. Right? So this will be equal to pi is 3.14 into D by 2. What is D by 2? 0.5 divided by 2. So 0.25 into 10 to the power minus 3 whole square divided by rho, that is 1.6 into 10 to the power minus 8. So this comes out to be 122.72 meters. So this should be the length of the wire to make its resistance 10 ohms. Now let us look at the second part of the problem. The second part asks how much does the resistance change if the diameter is doubled. So we have to calculate the new resistance. So let us suppose the new resistance is R dash. So we have to calculate the new resistance when it is told that the new diameter is doubled the earlier diameter. So D dash becomes equal to 2D. That is equal to 2 into the initial diameter was 0.5 millimeter. So that is equal to 1 millimeter, which can be written as 10 to the power minus 3 meters. So this is my new diameter. So therefore, the new resistance will be equal to rho L divided by A dash. Now here the diameter is doubled, so this will not affect the length at all. So this becomes equal to, what is rho? Rho is 1.6 into 10 to the power minus 8. What is L? L has been calculated as 122.72 divided by A dash would be equal to pi R dash square. So pi R dash would be pi D dash by 2 whole square. So this is equal to 1.6 into 10 to the power minus 8 into 122.72 divided by 3.14 into 4 into d dash square, that is 10 to the power minus 3 whole square. So this value comes out to be 2.5 ohms. So this would be the value of the new resistance if the diameter is doubled. Let us look at the next problem. It says that the value of current flowing in a given resistor for the corresponding values of potential difference V across the resistor are given below. That means the potential difference was changed from 1.6 volts to 3.4 to 6.7 to 10.2 and so on, and the corresponding values of current flowing through the conductor was also noted down. So plot a graph between V and I and calculate the resistance of that resistor. So first of all, let us try to plot the graph. So we take V along x-axis and we take current along y-axis. So let us say this is the origin. This is 2, 4, 6, 8, 10, 12, 14, and along y-axis I take 1, 2, 3, 4. So the first value of voltage is given as 1.6. So 1.6 would be somewhere here, and for a value of 1.6 the amount of current is 0.5. So 0.5 will be somewhere here and 1.6 will be somewhere here. So this is the point. The next one is 3.4 voltage. So 3.4 would be somewhere here and current is 1 ampere somewhere here. Next is 6.7 volts. So 6.7 would be somewhere here and this current is 2 amperes. Again next is 10.2, that is somewhere here, and the current is 3 amperes. Then you have 13.2 and the value of current is 4 amperes. Now if you join these points, what do you get? You get a straight line. So this shows that current is directly proportional to voltage. Now you have to calculate the resistance of the resistor. Now from Ohm's law, we know that V is equal to IR. So we can say that resistance is equal to V divided by I. So looking at this graph, you can take any point, take any of these points. There are a total of 5 points. Now take any of these points. Let us suppose if I take these points. So what are the values of current and voltages here? What is the value of voltage here? For this point? For this point the voltage is 6.7 volts and current is 2 amperes. So if we take these values, what would be the value of voltage? That is 6.7 and current is 2. So the value of resistance comes out to be 3.3 ohms. So this would be the value of the resistance. So not only this point, if you take any point on this straight line, the value of the resistance will come out to be same because it is a straight line. So the slope of this line will remain the same everywhere. Let us look at the third problem. It says when a 12 volts battery is connected across an unknown resistor, there is a current of 2.5 milliamperes in the circuit. Find the value of the resistance of the resistor. So what is given here? A battery of 12 volts. That means this 12 volts battery is capable, this battery is capable of producing a potential difference of 12 volts. Right? I told you before also that potential difference is created by, it is generated by cells or batteries. Right? So what is the amount of current that is flowing through the circuit? That is 2.5 milliamperes, which can be written as 2.5 into 10 to the power minus 3 amperes. So we have to calculate the value of the resistance. So using Ohm's law, we can say that V is equal to IR. So from this we can say R is equal to V by I. That is equal to 12 divided by 2.5 into 10 to the power minus 3. So this comes out to be 4.8 into 10 to the power 3 ohms. That is equal to 4.8 kilo ohms. So this would be the value of the resistance of the resistor. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again. Hello friends, this video on electricity part 7 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 6 before going ahead with part 7. So with this, we have a better understanding of Ohm's law. Let us now talk a bit about electric circuits, because in this lesson I will tell you how do we draw electric circuits. There are certain conventions which we follow to represent the different electronic elements in a circuit. Now, how do we represent an electric circuit? An electric circuit is represented by a circuit diagram. Like for example, when we were going through the lesson on light, when we were studying about reflection, refraction and image formation, we were representing the image formation with the help of ray diagrams. Similarly, we will represent electric circuits with the help of circuit diagrams. Now, how do we draw circuit diagrams? Circuit diagram is drawn using the conventional symbols of different circuit elements, because whenever we talk of any electric circuit, that circuit will have several elements, right? That circuit will have resistors, it can have inductors, it will have batteries, it will have wires, it will have switch, it will have voltmeter, it will have ammeter. So there are so many things that will be present in a circuit. So how do I represent all those things? So there are some conventional symbols which are used for each of the circuit elements. So now I will tell you about all such symbols. So generally, whenever we want to represent a wire in a circuit, how do we represent? We represent it by a straight line. Suppose if I want to represent a cell, we represent it in this way. So this represents the positive terminal and this represents the negative terminal. Now let us suppose if I want to represent a battery or a group of cells. In that case, we can represent it like this. So this bigger one is the positive terminal, smaller one is the negative terminal. So this is how we represent a battery or a group of cells. How do I represent a switch or a key? A key or a switch. It is sometimes known as key, sometimes known as switch. It is represented as this. So when it is represented like this, that means the key is open or the switch is open. So that means the switch is off. Sometimes the key is also represented like this in a circuit. So both of them mean the same thing. That means no current flows in the circuit. The switch is off. Now if you want to represent a key or a switch which is closed, then you represent it with a dot. And this one you represent like this. That means the key is closed. You have pressed it. That is what it means. Right? So this means the switch is off. This means the switch is on. How do I represent resistance? Resistance is represented like this. Now it is represented like this if the resistance has a fixed value. I mean, if I know that, okay, the resistance of this object is 2 ohms. The resistance of this object is 5 ohms. If it is of fixed value, then it is represented like this. But if you want to represent a variable resistance, now what do I mean by variable resistance? Sometimes I want to keep a variable resistance so that during my experiment or during the operation of the circuit, the resistance should be able to change its value on its own. That kind of resistance is known as a variable resistance or a rheostat, and that is represented like this. So this represents a variable resistance, so that this resistance can change its value depending upon the requirements of the circuit. Now, how do I represent an ammeter? What is an ammeter? It is an instrument which is used to measure current in a circuit. Like how we have voltmeter to measure voltage or potential difference. So this is denoted by A. So this is how we represent ammeter. Similarly, we represent a voltmeter. In that case, we will have V to represent voltmeter. Now, how do we represent wires which are joined? Let us suppose there is one wire going like this, there is another wire going like this, but these two wires are joined. That means this wire is joined to this wire, this is joined to this is joined to this. This is how we represent. But if I want to represent that wires are crossing each other without joining, wires cross without joining, how do we represent that? That is represented in this way. That means this is one wire and this is another wire, but these two wires are not connected. So that this is how it is represented. But in this case, it means that this wire and this wire are joined at this point. So when we draw circuit diagrams, all these things make difference, right? Because looking at the circuit diagram, sometimes you first draw the circuit diagrams and then you actually make the circuit in your lab. Right? So now how does a circuit look like taking into consideration all the circuit elements? Let us suppose if I have a circuit where I have a switch, I have a battery, I have a resistance, and then I have a bulb which is connected to the circuit. So how do we draw that circuit? First of all, I have a battery or a cell. This is positive, this is negative. This is connected to a resistance, which in turn is connected to a bulb. And then there is a switch in this circuit. So this resistance is of resistance R. This is a battery which can produce a potential difference of V volts, and this is a key. As long as the key is open, there will be no current flowing in the circuit. So the bulb will not glow. Now as soon as you close the switch, as soon as you switch it on, what happens? The bulb starts glowing. Right? So this is how we draw circuits with the help of these conventional symbols of circuit.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
Hello friends, this video on electricity part 9 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 8 before going ahead with part 9. So let us try to look at some of the problems based on these calculation of equivalent resistance. Let us suppose if a circuit is given like this and I ask you to calculate the equivalent resistance of this circuit between these 2 points A and B. So what will be in order to find out the equivalent resistance, first see how is the current flowing in the circuit. Now these two dots, these two bubbles show that these two are connected to the remaining circuit, I mean some battery or something. So this completes the circuit. So let us suppose some current I flows through the circuit. When I reaches at this point, it has an option to move through this resistance and another option to move through this resistance. But if you look at this resistance is in air. It is not connected to anything. So the current cannot flow through this because current will never flow. I mean, let us suppose if you keep a piece of wire on the ground, will current flow through it? It will not flow, because in order that current flows through a circuit, the circuit has to be a closed circuit. There has to be a battery connected to the circuit which will provide the potential difference between the two ends of the wire. But in this case, if you see, this wire is hanging in air, so no current can flow through this wire. So the entire current will flow through this resistance. So what do you see here? The amount of current flowing through this resistance and this resistance is the same. That means what kind of combination is this? It is a series combination, because same current flows through both the resistances. So what will be the equivalent resistance? Equivalent resistance will be the sum of the resistances, that is 7 plus 5 ohms, which is equal to 12 ohms. So 12 ohms would be the equivalent resistance of this circuit. Let us look at the next problem. Here also we will have to calculate the equivalent resistance between these 2 points A and B. So let us assume that some current I flows through this resistance. It reaches this point. Now it has two options. Either it can move through this path or it can move through this path. Now if you see, if the current moves through this path, it will have to overcome these resistances which will try to oppose the current. But if it moves through this path, there is no resistance at all. So what do you think? Which path will current prefer? So current will prefer to move through this path because there is no resistance along this path. So the entire current will flow through this path and there will be no current flowing through this path. Since no current flows through this path, therefore these two resistances doesn't play any role. So that means the current flows through this 3K resistance and then it flows through 5K resistance. This shows that, so from here we can see that, let us call this as CD. No current flows through CD, and we also see that same current flows through 3 ohms, that is 3K and 5K. Therefore 3 kilo ohms and 5 kilo ohms are in series. So what would be the equivalent resistance? That will be equal to 3K plus 5K, that is equal to 8K. So this would be the equivalent resistance of this combination. Let us look at problem number 3. It says a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash is which of these options? So now you have a piece of wire R which is cut into 5 equal parts. So each part will be R by 5. That means you have 5 resistances, each of resistance R by 5, and you have connected each of them in parallel. So this will how the parallel combination will look like. Both of their ends are joined to each other. So the value of each of them is R by 5. Now the value of equivalent resistance is R dash. So R dash is the equivalent resistance of this circuit. So let us try to calculate the equivalent resistance. Now from parallel combination we know that 1 by R equivalent is equal to 1 by R dash will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. So now in this case, value of R1 is R by 5. So this becomes 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. So this gives 1 by R dash is equal to 25 by R. Or we can say that R by R dash is equal to 25. So the ratio R by R dash will be equal to 25. So this is the correct answer. Let us look at the next problem. It says that a battery of 9 volts is connected in series with resistors of 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms respectively. How much current would flow through the 12 ohm resistor? So it says that there are these 5 resistors which are connected in series, and there is a battery which is connected to this series combination. So let us suppose this is 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms, and this is a battery of 9 volts. So we have to calculate the amount of current which will flow through the 12 ohm resistor. Right? Now if you look at it, this is the positive terminal of the battery, this is the negative terminal. So current will, the direction of conventional current would be from positive to negative. So that means this is how current will flow. Now since these resistors are connected in series, same amount of current will flow through each of the resistor. So the amount of current which will flow through this 12 ohm resistor is also I. So what will be the value of I? For that, let us calculate the equivalent resistance of the circuit, which will be equal to R1 plus R2 plus R3 plus R4 plus R5, because it is a series combination. So this will become 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So this becomes 13.4 ohms. Now applying Ohm's law to this circuit, what do we get? The net voltage potential difference of the circuit V will be equal to I, current flowing through the circuit, into the equivalent resistance of the circuit. So from this we can say I will be equal to V divided by R equivalent. So V is equal to 9 volts divided by 13.4 ohms. So this is equal to 0.671 amperes. So 0.671 ampere current will flow through each of these resistance. So this is the amount of current which will flow through the 12 ohm resistor as well. Let us look at problem 5. It says how many 176 ohm resistors in parallel are required to carry 5 amperes on a 220 volt line. So that means how many resistors do you need such that the resistance of each resistor is 176 ohms, so that you are able to carry a current of 1 ampere on a 220 volts line. So what is the net equivalent resistance needed? So from the entire circuit, how much current do we want? We want a current of 5 amperes. What is the net potential difference across the circuit? That is 220 volt. So according to Ohm's law, V should be equal to I into R equivalent of the circuit. So R equivalent will be V divided by I. That is equal to 220 divided by 5. So this becomes 44 ohms. So this should be the equivalent resistance of the entire circuit. Now let us say that we would need n resistors. So now we have to calculate the value of n. So if I say that I need n resistors to achieve an equivalent resistance of 44 ohms, what does that mean? That means that 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. How many times? N times, because I say that there will be n resistors. Now the value of each of these resistances is 176 ohms. That means their values are same. So we can write 1 by R plus 1 by R plus 1 by R. So how many times? N times I will add. So I can write it this way, that 1 by R equivalent is equal to n divided by R, because adding 1 by R n times means multiplying 1 by R with n. Right? So from this we can say n is equal to R divided by R equivalent. What is R? R is the value of each resistance, which is 176 ohms, and R equivalent is 44 ohms. So this gives 4. So we need 4 resistances in parallel so that it can carry a current of 5 amperes on a 220 volts line.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
Hello friends, this video on electricity part 10 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 9 before going ahead with part 10. Let us look at problem number 6. It says, show how you would connect 3 resistors, each of resistance 6 ohms, so that the combination has a resistance of 9 ohms and 4 ohms. So let us first look at the first part. So in the first part, I want the equivalent resistance to be 9 ohms. And how many resistors do we have? We have 3 resistors, each of resistance 6 ohms. Now we are aware of 2 possible combination. One is the 3 resistors connected in series, and the other one is the 3 resistors connected in parallel. Now if you connect the 3 resistors of 6 ohms in series, what will be your equivalent resistance? 6 plus 6 plus 6, that is 18 ohms. So that is not our desired resistance, which is 9 ohms. Now if you connect them in parallel, what will you get? we will get 1 by R equivalent is equal to 1 by 6 plus 1 by 6 plus 1 by 6. So this will give R equivalent as 2 ohms. So again, that is not our requirement. We want 9 ohms. So there is one possibility that what we can do is we can put 2 resistors in series and then we can put their combination in parallel with the third resistor. There is another possibility that we take 2 resistors in parallel and then we take that combination in series with the third resistor. So in this case, let us try the first one. Let us suppose if I assume that 2 resistors are in parallel. So if 2 resistors are in parallel, what would be the equivalent resistance? The equivalent resistance will be 1 by 6 plus 1 by 6, that is equal to 2 by 6, or Rp will be equal to 3 ohms. Now we told that 2 resistors are in parallel. Now with these 2 resistors in parallel, the third resistor is now put in series. Now the parallel combination of these 2 resistors gives 3 ohms. So now this 3 ohms, that means instead of these combination, we can say the value is 3 ohms. Now this 3 ohms is in series with 6 ohms. Therefore, R equivalent will be equal to Rp plus 6 ohms, that is 3 plus 6, which is equal to 9 ohms. So that is our desired result. So this would be the desired combination. Now let us look at the second part where we want R equivalent to be equal to 4 ohms. In this case, let us say that 2 resistors are connected in series. That means this is how we first connect 2 resistors of 6 ohms each. So what would be the series equivalent resistance of these two? 6 plus 6 equal to 12 ohms. Now with these 2 resistors in series, let us connect the third one in parallel like this. So what will happen? 1 by R equivalent will be equal to, now these two can be replaced with Rs because the equivalent resistance of these two is Rs. So this can be written as 1 by Rs plus 1 by 6. So this implies 1 by R equivalent is equal to 1 by 12 plus 1 by 6. So this implies R equivalent is equal to 4 ohms, that is the desired resistance. So therefore this would be the desired combination of the resistors. Let us look at problem number 7. It says a hot plate of an electric oven connected to a 220 volt line has 2 resistance coils A and B, each of 24 ohm resistance. Okay, so that means there are 2 resistances A and B, each has resistance 24 ohms. So there is one resistance A, there is another resistance B. Now they may be used separately, they can be used in series, they can be used in parallel. That means you can put these 2 resistances in series, you can put them in parallel, you can use them separately as well. So what are the currents in the 3 cases? So the first case is when you use them separately. So when you use them separately, what is the resistance? The net resistance is 24 ohms because only one of them is used. I mean both of them are used separately. So in one of them the resistance is 24 ohms and what is the voltage? Voltage is 220 volts. Therefore in accordance with Ohm's law, current will be equal to V by R, that is equal to 220 divided by 24, which is equal to 9.166 ampere. So this would be the current when they are used separately. Let us look at the second case where we say that they are connected in series. If they are connected in series, what would be the net resistance? That will be equal to R1 plus R2, that is equal to 24 plus 24, which is equal to 48 ohms. However, voltage in this case will remain the same, that is 220 volts. Therefore, current in this case will become V divided by Rs, that is equal to 220 divided by 48, that is equal to 4.58 amperes. Now let us look at the third case where we say that these two are connected in parallel. In this case, what would be the equivalent resistance of the combination? That will be equal to 1 by R1 plus 1 by R2, that is equal to 1 by 24 plus 1 by 24, that is 1 by 12. So we can say that Rp is equal to 12 ohms, voltage is equal to 220 volts. Therefore, current will be equal to V divided by Rp, that is equal to 220 divided by 12, which comes out to be 18.33 amperes. So this would be the current when they are connected in parallel.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
Hello friends, this video on electricity part 11 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 10 before going ahead with part 11. We will now talk about heating effects of current. So what actually we are going to study in this topic is that whenever electric current flows through a circuit, there is some amount of dissipation of heat which takes place. So now we will see that how is that heat utilized in different kinds of electrical appliances. So what do we mean by heating effect of current? It means dissipation of source energy in the form of heat in an electric circuit. As I mentioned before, in any electric circuit, there is a source of energy. For example, when I talk of this electric circuit which you see here, you have this battery. So this battery acts as the source of the potential difference, right? It provides the potential difference. And because of this potential difference, there is an electric current which flows in this circuit. Now the amount of energy which comes from this source, some portion of this source energy is dissipated in the form of heat. So this is known as heating effect of current. So now we will see how is this dissipated heat utilized in many different ways. So let us consider this circuit and let us suppose that current I flows through this circuit. When this key is closed, some amount of current I flows through this circuit. So current flows through this resistance R, right? So let us say work done in moving a charge Q through a potential difference V. Let us suppose the potential difference provided by this source is V. That is the potential difference between these 2 points. That means right now we are concentrating across this resistor. We say that amount of current through this resistor is I and the potential difference across this resistor is V. So what is the work done in moving a charge Q through this potential difference V? What would be the work done in moving a charge Q through a potential difference V? What will be the work done? That will be equal to Q into V. That is charge into potential difference. So what is the power input to the circuit? How much power is provided to the circuit? Power is always equal to work done per unit time, right? So work done is Q into V divided by time. Now charge per unit time is current. So this is equal to VI. So therefore we can say that this is the power, this much is the power supplied to the circuit. So how much is the energy supplied to the circuit? The energy supplied to the circuit will be equal to power into time, because power is nothing but energy per unit time. So this will be equal to VI into T. So this much is the total amount of energy that is supplied to the circuit. So we can say this is the total source energy. Now this energy is dissipated as heat across these resistance R. So how much is the heat dissipated? Heat dissipated H is equal to VIT. Now from from Ohm's law, we know that V is equal to IR. So we can put V is equal to IR. So we get H is equal to I square RT. This is known as Joule's law of heating. This is called Joule's law of heating. So according to Joule's law of heating, if you have a circuit where there is a source which provides some amount of source energy because of which a current I flows through the circuit, then the heat that is dissipated across the resistor is given by I square RT, where R is the value of that resistance and I is the current flowing through the circuit, right? So this heat is useful for many different applications. We will look at some of those applications in the next few slides. So from Joule's law of heating, what did we conclude? We conclude that the heat produced in a resistor is directly proportional to the square of the current, because H is equal to I square RT. So it is directly proportional to square of current. It is proportional to the value of resistance for a given current. It is directly proportional to the time for which the current flows through the resistor. So this also tells us that if current keeps on flowing through a circuit, the resistor gets heated up gradually, right? Because some amount of heat is getting produced across the resistor. So the resistor will get heated up in due course of time. Let us now look at some of the applications of heating effects of current. That means the heat which is dissipated when electric current flows through a circuit, we will see how does that heat get utilized for some important applications. Examples of such things would be electric heater, electric kettle, electric iron, electric bulb. All these things make use of heating effects of current. So let us look at this electric bulb. If you observe an electric bulb closely, you would see that there is a filament inside the bulb. And that filament retains most of the heat that is generated during the flow of electric current through the circuit. So whatever heat is generated across the resistor, that is stored by this filament, and this filament is made up of tungsten. Now why is it made up of tungsten? Because tungsten has very high melting point, so that even though it accumulates so much of heat in itself, it does not melt. So what happens? The filament becomes hot, and when it becomes hot enough, it starts emitting light. So in a bulb, you have a filament made of tungsten. So this filament retains most of the heat generated, and when it becomes sufficiently hot, it emits light. So now what we do, this tungsten, this filament is thermally isolated so that so much of heat doesn't damage the other parts of the bulb. Most of the power consumed by the filament is given as heat, and a very small portion of it is given as light. So most portion is given as heat and some is given as light. Right, so in this way we see that in bulb, electrical energy also gets converted into heat energy and light energy. Let us look at another important application, that is electric fuse. You would have seen that there is something called fuse at your home. What is the purpose of the fuse? It prevents excessive flow of current through the circuit. As I mentioned, sometimes excessive flow of current can damage the different components present in the circuit. So in order to prevent that, fuse is used. So fuse is connected in series with a device, and so because the amount of current which flows through, if you connect two things in series, same amount of current will flow through each of them. So let us suppose if some excessive amount of current I is about to flow through the device, the same current will have to pass through the fuse first. Now what does a fuse do? Fuse is nothing but it consists of a wire which is made up of some metal of specific melting point. For example, this kind of fuses are the ones which you generally see at your homes. So if you see, it consists of a wire, this wire. So this wire is made up of a metal of specific melting point. Now as current increases and it increases beyond a certain limit, this wire will break because it will reach the melting point of the wire and the wire breaks. And once the wire breaks, your circuit breaks. And the circuit breaks means no current further flows in the circuit. So we have to choose this wire appropriately. We should not choose a wire of very high melting point. In that case, it will allow very high amount of current to flow through it, because it will not melt easily. So we need to choose an appropriate melting point, so that as soon as the current increases beyond a certain limit, the wire melts and the circuit becomes an open circuit, or the circuit breaks and current cannot further flow through the circuit.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
Hello friends, this video on electricity part 12 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 11 before going ahead with part 12. Now we will introduce another important, let us now define another quantity associated with it, that is electric power. So just now we saw that the source energy got dissipated as heat across the resistor in the electric circuit. Now the rate at which this energy gets dissipated in the circuit is known as electric power. Normally we have talked about power in one of our previous lessons, where we say that the rate of doing work is defined as power. So in this case also, since we are talking about electric circuits here, so here the rate at which the electric energy is dissipated, that means the rate at which work is done in bringing the charged particle from one point to another, that is defined as electric power. So it is denoted by a capital P. The SI unit is similar to power, that is watt. So how do I define 1 watt? It is defined as the power consumed by a device carrying 1 ampere of current when operated at a potential difference of 1 volts. Because power is equal to VI. That is what we derived in the last slide, right? So if I want to define 1 watt, it has to be 1 volt multiplied by 1 ampere of current. So the power consumed when 1 ampere of current is operated, when 1 ampere of current passes through the device when operated at a potential difference of 1 volts. Now applying Ohm's law, we can also write that power is equal to V square by R, or power is equal to I square by R. Let us now try to solve few problems based on whatever we studied so far. So here comes problem 1. It says, several electric bulbs designed to be used on a 220 volts electric supply line are rated as 10 watts. How many lamps can be connected in parallel with each other across the two wires of 220 volts if the maximum allowable current is 5 amperes? So in this case, the bulb is rated as 10 watts. That means the power is 10 watts. And what is the supply line? That means what is the potential difference from the source? That is 220 volts. Right? So using this value of power and potential difference, we can calculate the value of resistance. We know that P is equal to V square by R. So using this, we can say P1 is equal to V1 square by R1. So from this, we can calculate R1 as V1 square by P1, that is equal to 220 into 220 divided by 10. So this comes out to be 4840 ohms. Now it says that there are several electric bulbs which are connected in parallel so that the maximum allowable current is 5 amperes. So now we are able to calculate the value of each resistance, but we don't know how many such resistances are connected. So let us suppose that the number of bulbs is n. So we assume that the number of bulb is n and resistance of each such bulb is 4840 ohms, right? So what would be, and all these bulbs are connected in parallel, that is also mentioned in the problem. So what would be the equivalent resistance of that combination? 1 by Rp, if Rp is the equivalent resistance, will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. This will be added for n times because I have assumed that the total number of bulbs is n. So now we can say that 1 by Rp will be equal to 1 by, now the values of R1, R2, R3, all these values are same, they all are 4840. So we can replace them by R. So we can say this is equal to n by R. So from this we can say that Rp is equal to R by n ohms. Right? R or R1, whatever you want, you can replace it with any of these. So now we know the value of R1. Now for the entire circuit as a whole, if you look at the circuit as a whole, how much current is allowed to be flown in the circuit? The maximum allowable current is 5 amperes. And what is the potential difference across the circuit? That is 220 volts. So using this data from Ohm's law, we can calculate the value of equivalent resistance of the circuit. So if the equivalent resistance of the circuit is Rp, we can say V is equal to I into Rp. Right? So from this we can calculate Rp as V by I. That is equal to 220 divided by 5, which comes out to be 44 ohms. So now we make use of this equation and we say that N is equal to R1 by Rp. So R1 was 4840 ohms. So put it as 4840 divided by 44. So this comes out to be 110. So that means in order that a current of 5 amperes flows through this circuit, we will have to connect 110 electric bulbs in parallel with each other. Let us look at the next problem. It says, compare the power used in the 2 ohm resistor in each of the following circuits. The first circuit is a 6 volt battery in series with 1 ohm and 2 ohm resistors. So how will the circuit look like? So let us look at the first part first. So you have 2 resistors, 1 ohm and 2 ohms, and they are connected with a battery of 6 volts. So this is a battery of 6 volts. So we have to compare the power used in the 2 ohm resistor. So we have to calculate the power across this resistor. Now let us first look at how will the current flow in this circuit. Let us suppose some current I flows through the circuit. The same amount, since these 2 resistors are in series, so the same amount of current will flow through each of these resistors. So let us try to calculate the current flowing through this circuit. What would be the equivalent resistance of the circuit? 1 ohm plus 2 ohms, which is equal to 3 ohms. Now the current through the circuit will be equal to V divided by R equivalent from Ohm's law. V is 6 ohms, R equivalent is 3 ohms. So this gives 2 amperes. So that means 2 amperes of current will flow through this circuit. So now concentrate on the 2 ohms resistor, because we have to calculate the power used in this 2 ohm resistors. Now what is the current flowing through the 2 ohm resistors? 2 amperes. So current through 2 ohm resistor is equal to 2 amperes. Therefore power across the 2 ohms resistor will be equal to I square R. What is I? I is 2 ampere into R. R is again 2 ohms. So this is equal to 8 watts. So that means 8 watts of power is used in the 2 ohm resistor. Let us look at the second part of the problem. It says there is a 4 volt battery in parallel with a 12 volt and 12 ohms and 2 ohm resistors. This means here you have 2 resistors which are connected in parallel with a battery of 4 volts. So this is a 4 volt battery. This is 2 ohms and this is 12 ohms. So in this case, first of all, in this case also we have to calculate the power used in this 2 ohm resistor. So for this, we will have to calculate the current through this resistor. Now what is the potential difference across these resistors? The potential difference across these 2 points is 4 volts. Potential difference across these 2 points is also 4 volts. Therefore, let us first calculate the current through 2 ohm resistor. That will be equal to V by R as per Ohm's law. So V is equal to 4 volts divided by R is 2 ohms, which is equal to 2 amperes. So here also 2 amperes of current flows through this 2 ohm resistor. Therefore, the power through 2 ohm resistor will be equal to I square into R, which is equal to 2 square into 2, that is equal to 8 watts. So in this case also, the amount of power that is used in the 2 ohms resistor is 8 watts.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
Hello friends, this video on electricity part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 12 before going ahead with part 13. Here comes problem 3, which says 2 lamps, one rated 100 watts at 220 volts and the other 60 watts at 220 volts are connected in parallel to electric mains supply. Okay, so P1 for the first lamp, power is 100 watts. For the second lamp, power is 60 watts. The potential difference for the first one is 220 volts and the potential difference for the second one is also 220 volts. Now it says that they both are connected in parallel to electric mains supply. So what current is drawn from the line if the supply voltage is 220 volts? So let us see how much current will flow through this first bulb. So the current through this will be equal to P1 divided by V1. That's because we know that power is given as the product of potential difference and current. So this will be equal to 100 divided by 220 amperes. Similarly, current drawn by the second lamp will be equal to P2 by V2. That is equal to 60 divided by 220 amperes. Therefore, total current drawn by these two bulbs will be equal to I1 plus I2. So total current drawn will be I1 plus I2, that is equal to 100 by 220 plus 60 by 220, that is equal to 160 by 220 amperes. This comes out to be 0.727 amperes. So this much amount of current will be drawn from the line. Let's look at the next problem. It says, which uses more energy, a 250 watt television set in 1 hour or a 120 watt toaster in 10 minutes? So let us try to calculate the energy for the first one. For the television set, power is given as 250 watts and time is given as 1 hour. So 1 hour would mean 60 into 60 seconds. Now for the toaster, power is given as 1200 watts and time is given as 10 minutes. So 10 minutes would mean 10 into 60 seconds. Now we all know that power is nothing but work done per unit time. That means energy per unit time. Therefore, we can say that energy is equal to power into time taken. So power is 250 into 60 into 60. So this comes out to be 9 into 10 to the power 5 joules. Again, in this, energy will be equal to power into time taken, that is equal to 1200 into 10 into 60. So this comes out to be 7.2 into 10 to the power 5 joules. So if you compare the value of E1 with E2, we see that E1 is greater than E2. That means the television set uses more energy than the toaster. Let us look at problem 5. It says an electric heater of resistance 8 ohms. So the resistance is given as 8 ohms, draws 15 amperes from the service mains in 2 hours. So the resistance of the heater is 8 ohms and the current it draws is 15 amperes in how much time? In 2 hours. So we have to calculate the rate at which the heat is developed in the heater. So in a way, we have to calculate the rate at which the energy is consumed by the heater. And what is rate at which energy is consumed? That is nothing but power. So that means we have to calculate power. Right? Now convert this time into seconds. It will be 2 into 60 into 60 seconds. Now, how do we calculate power? We know that power is given by I square into R. So we really don't need this amount of time for which it takes this much of energy. So power is I square R. So I square is given as 15 square into R is 8 ohms. So this comes out to be 1800 joules per second. So this is the rate at which heat is developed in the heater. Two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then in parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combinations would be which of these options? Now we know that heat produced is given by V square by R into T. Because we know that as per Joule's law of heating, heat produced is nothing but V into I into T. So applying Ohm's law, we can write it as V square by R into T. Now let us first look at the series combination. What would happen in series combination? Heat produced is denoted by Hs. This will become V square divided by Rs into T. What happens in parallel combination? In the parallel combination, Hp will be equal to V square divided by Rp into T. Now let us try to calculate the value of Rs, that is the equivalent resistance in series combination. This will be equal to R plus R because resistance of both the wires will be same. Because they are made up of same material, they have equal lengths and they have equal diameters. Because resistance is given by rho L by A. So if they are made of same material, that means rho will be same. They are of equal lengths, so L will be same. They are of equal diameters, therefore area will also be the same. Therefore the resistance of both the wires will be same. So let us assume that the resistance of each wire is R. So equivalent resistance in series combination will be equal to 2R. Equivalent resistance in parallel combination will become 1 by R plus 1 by R. This implies Rp will become R by 2. Therefore, the ratio of the heat produced in series combination to the parallel combination will be equal to V square by Rs into T divided by V square by Rp into T. So this V square and T will get cancelled. So we get Rp divided by Rs. Now Rp is R by 2 divided by 2R. So R will get cancelled and we get 1 by 4. So Hs by Hp will be equal to 1:4. So if you look at it, option C would be the correct option. So with this, we will conclude this lesson on electricity. So what all did we study in this lesson? We talked about what is electric current, what causes electric current to flow in a circuit, how do we draw circuit diagrams to represent electric circuits, what are resistors, how do we combine resistors in different types of combinations to get a desired value of resistance to complete a circuit. So these were some of the things which we discussed here, and we also talked about the heating effects of electric current.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.
If you look around your house, you will see many devices that have electric motors, such as kids' toys, table fans, toothbrushes, hair dryers, and this electric cutting knife. But how does the electric motor work? You turn it on and somehow it starts rotating. Why is that? In this video, we'll cover the basics of electricity and magnets, and then put it all together to understand how the motor works. This video is sponsored by Brilliant. Let's start with something called a circuit. You have a battery, some wires, and a device that uses electricity such as a light bulb. Electricity flows through the circuit. But as soon as there is a break in the wire, the electricity stops flowing and the light bulb goes off. The path must be complete for the circuit to work. This is best done through the use of a switch. Electricity is flowing down the wire. This is called conventional flow. If we take the battery out and flip it, then the current will flow the other way. The light bulb will still work in either case, but there are some devices that will work differently depending on which way the current flows. Okay, so that's the basics of a circuit. Now let's come over here. This is a magnet. It has a north pole and a south pole, and it likes to attract other metal objects like these paper clips. If you bring another magnet towards it, opposite poles attract, and the same poles repel. Magnets don't have to be in this shape. For example, some magnets might be more flat like this. You can think of this magnet as always on, it's always working, you can't really turn it off. That's why it's sometimes called a permanent magnet. It's made up of many smaller magnetic domains that are lined up in the same direction. But later I'll show you a type of magnet where this is not always the case. Let's take one of our permanent magnets and drill a hole in the center and put it on something that will allow it to spin. Now bring another magnet towards it. Our spinning magnet will immediately line up until opposite poles are right next to each other. Now switch out the side magnet. The same poles repel and opposite poles attract. If we keep switching out these side magnets, then our spinning magnet will just keep spinning. This concept of the spinning magnet is really important. We'll come back to it in a moment. Here's a metal bolt which is not a magnet. It's made up of magnetic domains, but they are pointing in random directions. Now let's take a wire, wrap it around several times, and then create a circuit. The current through the wires forces the magnetic domains to line up. That means we've just made a magnet, or more specifically, an electromagnet. It can do the same things that a permanent magnet can. It can pick up pieces of metal, and it has a north and a south pole which will attract or repel other magnets. But the electromagnet is special in the sense that it can be turned on or off, just like the light bulb. You can't do that with a permanent magnet. Now watch what happens when we flip the battery. The electric current was flowing this way, but now it flows the other way. This will cause the poles on our magnet to switch places. North will become south, and south will become north. This is called reversing the polarity of an electromagnet. Instead of flipping the battery, an easier way to do this is to just switch the wires. You should be aware that the electromagnet will get very hot if it's on for a while. Just a caution in case this video inspires any science projects. Let's come back to our spinning magnet. This time we'll replace the spinning magnet with our electromagnet. As soon as we connect the wires, the magnet turns on and it lines up with the side magnet. Now, in reality, connecting these wires would prevent the bolt from spinning freely, but what's important here is the concept of the spinning electromagnet. Now let's switch the wires to reverse the poles on the electromagnet. The same poles repel and opposite poles attract. Now reverse the polarity again. Same poles repel and opposite poles attract. If we keep switching the polarity, our electromagnet will just keep spinning. To make this stronger, let's bring in another permanent magnet on the side. Notice how this side has the south pole towards the center, and this side has the north pole towards the center. The side magnets work together to spin the one in the middle. This right here shows the very basics of an electric motor, but we need to make a few improvements. The two side magnets can be replaced with stronger curved magnets. And instead of a bolt with wires, we're going to use a metal loop. This is called the armature. Connect our wires and we have a circuit again. This time you can think of the electromagnet as flat like this with the south pole pointing up. Now the armature will spin until opposite poles are lined up. We can keep it spinning by switching the wires just like we did before. But this is a lot of work to sit here and manually switch these wires. We need to add something to the armature called a commutator. It's a ring with gaps on the opposite sides. The commutator will spin along with the armature. Now we connect the circuit with 2 brushes on the side. These brushes will slide along as the commutator spins, and they are spring-loaded so that they always maintain contact. The current flows from the wire, through the brush, the commutator ring, the armature loop, and back through the other side. Now we have our electromagnet and the armature spins. As we come around this time, the brushes will switch contact to the other side of the commutator ring. Remember, there's 2 brushes, so this is happening on both sides. Before the switch, the current in the armature is flowing this way. After the brushes switch sides, current will flow the other way. This means the electromagnet switches polarity, which will cause the armature to keep spinning. This commutator ring does the same thing as switching the wires like we were doing before, but this time it does it all on its own. It will continue to spin as long as we're connected to a battery. Disconnect the battery, no more electromagnet, and the spinning stops. Now so far we've only used 1 loop on the armature. This will cause our motor to have an irregular speed, and in fact, we could get stuck in this position, with the brushes halfway between commutator segments. What we can do is split the commutator ring and then add another loop. So first, the brushes are in contact with these 2 commutator segments, which turns on this electromagnet, which causes it to start spinning. Once we get to here, the brushes switch contact to the next pair of commutator segments, which means this loop turns off and the next loop turns on. Now this electromagnet wants to spin. The brushes switch contact and the next loop turns on. This keeps happening as our motor spins. It's almost like the loops will take turns being an electromagnet. Some electric motors will add many loops to the armature. This ensures that there will be a continuous spinning motion on the motor. This spinning force on the armature is called a torque. Stronger torque means a faster spin. There are some things we can do to improve the torque of the motor. Electromagnets are stronger when there are more wires. This is true when we wrap more wires around the metal bolt, and it's also true when each of our armature loops are made of many wires. The motor will have stronger electromagnets, which means it will spin faster. If you look at some pictures of real electric motors, you can see lots of wires wrapped around. And yes, this is the same reason. More wires wrapped around means stronger electromagnets. Another way to make this stronger is to use more electricity. Let's learn a few more terms here. The part that doesn't move is called the stator. In this case, it's the 2 permanent magnets on the side. These fit inside the edges of the motor case. The armature in the middle is also called a rotor. Remember, this is the part that spins. The axle goes through the middle here and then sticks out the back of the motor. What I've shown you in this video is called a DC motor. If you have a device that moves and is powered by a battery, there's a good chance there's a DC motor in it. Other types of electric motors will work a little differently than what I've shown here. No matter the type of motor, most of them will produce some type of spinning motion. Once it's spinning, we can use this to make different devices move. In this case, a kid's toy. Or even a fan that cools your room. The spinning of the motor can be converted to other types of movement, such as the side-to-side motion that we see in this fan. Or how about this electric cutting knife? Each blade is going back and forth. It all starts with the spinning of the motor to turn a gear, which then pushes these 2 pieces back and forth. So hopefully this video has made a few light bulbs go off in your brain. If you like learning new things, head on over to Brilliant. This is a problem-solving website and app that focuses specifically on math and science. The idea here is that you learn by doing. Pick a topic, it starts with the basics, but gradually it gets more complex as you go. For me, I've enjoyed how you can see these concepts visually, like the area of a circle. You get to see why the equation works. The best way to learn is to do it yourself. Master the concepts by solving fun and interactive problems. And look at that, they've even got a course on electricity and magnetism. You can learn more about the concepts you've seen in this video. Brilliant is great for anybody that is curious and likes to learn new things, whether you're a student learning it for the first time or a professional who wants to keep their skills sharp. Sign up for free by going to brilliant.org/JaredOwen. The first 200 people will also get 20% off their annual premium membership.